Good morning, leaders. We're from the group Grade Polymers, and I am Jake Lambersilio from Bachelor of Science in Mechanical Engineering.
And I am Raymark John D. Estron from Bachelor of Science in Mechanical Engineering 1.
And I am Raymark A. Lopez from Bachelor of Science in Mechanical Engineering.
Nofre Doloan, Bachelor of Science and Mechanical Engineering from Green Valley College.
Material chemistry involves the use of chemistry for the design and synthesis of materials with interesting or potentially useful physical characteristics such as magnetic, optical, structural, or catalytic properties. This material chemistry, it is a unique in providing the intellectual foundation to design, create, and understand new forms of matter. Let it be organic, inorganic, or hybrid materials. Also, involved in structure, properties, characterization, processing, and performance. Some examples include the water, soil, and smoke, silk, wood.
I will explain to you the polymers. What is polymers? Polymers derive from the word poly means many, while mers means parts. Are long chain molecules formed by repetition of many small simple chemical repeating units. The repeating units are termed monomers. These monomers can either repeat linearly or in the form of chain that are connected as branches to form a three-dimensional network. The monomers are linked with one another via chemical reaction by a process called polymerization. Who is the father of polymers? The father of polymers is Hermann Francis Mark. He was an Austrian-American chemist born on May 3, 1895. He was died on April 6, 1992. Mark was known as the father of polymer science. Mark's X-ray diffractions work on the molecular structure of fibers provided important evidence on the macromolecular theory of polymer structures. Classification of polymers. Polymers are classified on the basis of various categories as given below. In this category, polymers are classified on the basis of source of origin. Are natural polymers, semi-synthetic polymers, and synthetic polymers. So, the natural polymers and synthetic polymers will explain by Esteron Raymark John.
What is the difference between natural polymers and synthetic polymers? The natural polymers are made by the living organisms, while the synthetic polymers are made by the chemical reaction in a lab. The example of natural polymers are the DNA, rubber, cellulose, wool, and other living organisms. The synthetic polymers are the nylon, polyester, Teflon, epoxy, and other chemical reaction in a lab. The second classification of polymers on the basis of structure of polymers. We have the three classification, namely linear polymers, branch-chain polymers, and lastly cross-link or network polymers. The linear polymers, these are those polymers that have long and straight chain but no branches. Linear polymers, the repeating units are joined together end-to-end in a single flexible chain. Some of the common examples of linear polymers are the polythene, PVC, polystyrene, and polyamides. Linear polymers are generally more rigid. Next is the branch-chain polymers. These are those polymers that have long chain but also have some branches. Branch-chain polymers have side chains or branches going out from the main chain. One of the most common example is low density of polythene and has application ranging from plastic bags, containers, textiles, and electrical installation to coating for packing materials. And lastly, we have the cross-link or network polymers. These are the polymers that have a long straight chain, but these chains are connected through the strong covalent bonds. Cross-link polymers are polymers in which the adjacent polymer chain are connected in a three-dimensional network structure. The connections are also known as cross-links. Some common examples include epoxies, bulk, molding compounds, rubber, and various adhesives.
Homopolymers, the formation of addition polymers due to the polymerization of single polymeric species, is called a homopolymer. For example, polythene. Copolymers, the formation of addition polymers which occur due to by addition polymerization from two different monomers, is called a copolymer. For example, Bona S, etc. Condensation polymers. In these reactions, small molecules such as water, hydrogen, chloride, etc. eliminate. Some common examples include nylon 6, terylene, etc. Elastomers. Because of these weak interactions, these polymers have the elastic property. Some crosslinks are also present between the chains due to which these polymers are able to regain their original position. Some examples include Bona S, Bona N, etc. Fibers. They have strong intermolecular forces and thus have crystalline nature. Some examples include polyamides, polyester, etc. Thermoplastic polymers. Their intermolecular forces of attraction are intermediate between elastomers and fibers. Some common examples include polythene, polyester, etc. Thermosetting polymers. These polymers cannot be reused. Some common examples include bakelite, urea, formaldehyde resins, etc.
Comparing about step polymerization and the chain polymerization so that we can understand the difference between these two types of system. If you remember, in the step polymerization, the reaction just do the functional groups that are on the ends of monomers units, and those functional units then can react with each other to join monomers together. To join polymers with monomers and to join two polymers together, so a quick figure of that mechanism is that the molecular weight polymers is produced at the late stages of the reaction, because remember that in the early stages you have mainly monomers unit present. So the probability is the highest, so the reaction will occur between monomers or short fragment monomers. So in the early stages you build up a small of low molecule weight fragment, slow degrees of polymerization. Then in the later stages is become more likely that the growing longer chain will join together at the biggest fragments to form the largest polymers chain. A chain group polymerization is different because the reaction takes place at an active sites that form at the end of the monomers unit. So subsequent monomers are added at the active site. So an active site is formed and another monomers unit is added. That site is then transferred to the new end of the polymers chain, and the additional monomers units are added. So monomers added one by one to the end of the chain, and the active site is transferred to the chain. So as a result of this mechanism, high molecule weight polymers are formed very early in the reaction process, because those are parts of this. Those are the stages of the reaction where you have the most amount of monomers present in your reaction mix. So this is a key difference between step growth and chain growth polymerization, the way in which the process evolves over time.